Let's try to do some past paper questions relating to the topic Lesson 1 and Lesson 2. A curve is such that the dy dx equals to this one and passes through the point 1, negative 1, 9. The gradient of the curve at p is 2. Number 1, find the value of the constant k. Since the gradient at p is given, which is equal to 2, that is actually our dy dx. So to find number 1, that will be 6 times 1 squared plus k times 1 cube is equal to 2. That is 6 plus k is equal to 2. So that is k is equal to negative 4. How come I wrote that negative 4? Okay, now find the equation of the curve. So let's try to use the k, which is equal to negative 4. So therefore, the equation of the curve, that is y, is equal to the integral of 6x squared plus negative 4 over x cubed dx. Again, going back and reviewing for the techniques of integration, we cannot integrate yet because we can see like there is a quotient here. So what we're going to do is to rewrite that problem. So minus 4x to the negative 3 dx. And then now we are ready to integrate. So this is x2 plus 1 over 2 plus 1. And then just simply multiply the 6 over there, minus 4. And then you integrate the x to the negative 3 plus 1 over negative 3 plus 1 plus c, which is now equal to 6x raised to cube divided by 3. So this will be 2x cubed, negative 2 here, so that's going to be positive 2, x raised to negative 2 plus c. So that is now your y, but then we can rewrite as 2x cubed plus 2 over x squared plus c. However, the problem says that it's passing through the 0.19. So therefore, we need to find the c by plugging in that value. So 9 is equal to 2 times 1 cubed plus 2 over 1 squared plus c. So 9 is equal to 2 plus c. So c is equal to 5. So therefore, the question is y is equal to 2x cubed plus 2 over x squared plus 5. Yeah, that's it. All right. Okay, so that's our values of k. Then we get 5 marks in this question. Hey, let's proceed to the next example. The function f is such that the first derivative is equal to 3x squared minus 7. F of 3 is equal to 5. Find f of x. So therefore, we have there now, again, we're looking for the f of x, and the f of x is the integral of the derivative of 3x squared minus 7 dx. Since this is very straightforward, we don't need the strategies that we have learned a while ago. So let's take the integral immediately. So this is going to be 3x cubed over 3 minus 7x. Minus 7x, and please don't forget the plus c. Alright? Or you're going to say that f of x is equal to x cubed minus 7x plus c, and it's passing through the point 3,5. Why 3,5? Because of that one. X value, f of x equals 3, and that is your y value, 5. So let's plug it in. 5 is equal to 3 cubed minus 7 times 3 plus c. So 5 is equal to 27 minus 21 plus c. 5 is equal to, what? 6 plus c. So therefore, c is equal to negative 1. So therefore, our f of x is equal to x cubed minus 7x minus 1. Let's check the answer. X cubed minus 7x minus 1. Correct. Okay. Next, let's proceed to the next question. Oh, this is exactly similar to the first one. So you just need to take the integral. Again, the function of x is equal to the integral of the derivative 5 minus 2x squared dx. Okay, so the f of x then is equal to 5x minus, sorry, that's a little bit ugly handwriting, that is 2 over 2x cubed over 3 plus c. Alright, and then it's passing through the point 3,5. So now we're going to plug in 5 is equal to 5 times 3 minus 2 over 3 times 3 cubed plus c. So 5 is equal to 15 minus, cancel is squared, 9 times 2, negative 18, plus c. 5 is equal to negative 3 plus c. So c is equal to 8. So therefore, the final answer is y is equal to the function of x is equal to 5x minus 2 over 3x cubed plus 8. Is it? Yes. Okay, that's it. So now let's proceed to the next example. How many more minutes do we have here? We have 6 minutes here, so let's continue. Take a look that in this question, this is 9 marks, and a curve is such that you know the second derivative is equal to 4, and then the curve has a stationary point. Remember, stationary point at p equals x equals 2. Stationary point meaning y prime is equal to 0. state with the reason the nature of the stationary point. Again, what do you mean by nature? The nature is either minimum or maximum. So how you're going to do that is that you take the second derivative value at x equals the stationary point at x equals 2. So that will be 24 over x cubed. So that is 2 cubed minus 4. And what is this one? So 24 over 8 minus 4. So what is that? 24, 3 minus 4. That's equal to negative 1. Since the second derivative, okay, is equal to negative 1, is less than 0. Again, if it's less than 0, meaning it opens downward. So therefore, the stationary point is here, it's maximum. Stationary point is maximum. There you go. Find an expression for dy dx. Guys, remember, the dy dx is equal to the integral of the second derivative of y with respect to your x. So let's try to get the second derivative of this one. That's 24 over x cubed minus 4 dx integral. But again, we cannot continue with the integration because we have here a fraction, so we need to rewrite it first. Okay, so the integral of 24x to the negative 3 minus 4 dx. Now we can apply our integral. So 24x to the negative 2 over negative 2 minus 4x, and please don't forget your plus c. Okay, and remember, this is your dy dx, not your f of x. So the dy dx then is equal to negative 12x to the negative 2 minus 4x plus c. Now we need to find the just the expression, right? Well, we need to find the what do you call this one? We need to find the c. Oh, we cannot find. Okay. Oh, we can, because the y derivative, if x equals 2, the first derivative is equal to 0. So let's use that one to solve for the c. So again, y prime is equal to 0 at x equals 2. So 0 is equal to negative 12 over 2 to the power of 2 minus 4 times 2. Is it 2? Just to make sure, yeah, 2. Plus some c. So 0 is equal to negative 12 divided by 4, negative 3 minus 8 plus c. So c is equal to 11. So the dy dx then, the dy dx is equal to negative 12x to the negative 2 minus 4x plus 11. Alright, then what is now the question? Given that the curve passes through the point 113, find the coordinate of the stationary point P. Alright, so yeah, we need, remember, you're looking for the curve. The curve passes through that point. So what you're going to do is you take the integral. So the y is equal to the integral of your dy dx with respect to x, which is equal to the integral of negative 12x to the negative 2 minus 4x plus 11 with respect to x. So now we can integrate because this is something easy. So negative 12x to the negative 1 over negative 1 minus 4x squared over 2 plus 11x plus some number c. Alright, so let's just simplify this before we continue. So y is equal to 12x to the negative 1. Or you know what about if I just put this one as over x? I think that is better. Minus 2x squared plus 11x. Okay, plus c. And it is passing through the point, what, 113. Since it is passing through the point 113, so let's substitute 1 comma 13. So 13 is equal to 12 over 1. 12 minus 2 times 1 squared is 1 plus 11 plus c. So therefore 13 is equal to 12 minus 2 is what? 10 plus 11 is 21 plus c. So therefore c is equal to negative of your 8. So therefore the final answer is y is equal to 12 over x minus 2x squared plus 11x plus, not plus, but minus 8. Alright, so that's actually a good one. In 13 minutes, we would be able to finish a lot of questions. Okay. Alright, so that's all for this, and yay! See you on the next video. Have a good day.